Earth, 450 million years ago. It is a thriving water world, filled with strange and amazing creatures. An ocean paradise. But a killer from space is heading this way. Throughout the Earth's history, catastrophic events have caused numerous mass extinctions. But each time total annihilation seems inevitable, nature snaps back with remarkable resiliency. These mass extinctions are a brutal part of our past and could be part of our future. Who will live and who will die? The answers may surprise you. Now witness the first mass extinction in the planet's history. Death rays on Animal Armageddon. It is not the strongest of the species that survives, nor the most intelligent. It is the one that is the most adaptable to change. Charles Darwin, 1859. Our planet's first great mass extinction begins 500 million years ago. Long before humans, long before even the dinosaurs. A controversial theory suggests this cataclysm could have started 6,000 light-years from Earth. A dying star in the Milky Way implodes and goes supernova. Massive beams of energy shoot from its poles. A gamma-ray burst. These are the largest explosions in the known universe. The 10-second blast contains more energy than 1,000 suns. The lethal rays rush violently through the cosmos at the speed of light, on a collision course with a small blue planet, Earth.
If it were close enough, it would blow the atmosphere off the planet. They were sitting 1 minute in this beautiful, nice, cloudy day, and then boom, where'd the air go? And it is literally blown off into space.
Given that gamma ray bursts are the most destructive things that happen in the universe, if these things happen close enough, there's just no possibility that any type of life could survive such an event. It would literally eviscerate the entire surface of the planet, burn it to a crisp. Nothing could survive.
No one's sure what caused this mass extinction. The gamma ray burst is one compelling theory. If true, then the countdown to mass extinction of all life on planet Earth has begun. Thousands of light years from the rocketing death rays, Earth orbits peacefully, unaware of the impending doom. This is a glimpse 450 million years into the past, the Ordovician period, a vastly different world from today. The continents as we know them now are still part of several landmasses. Gondwana encompasses Australia, Africa, Southern Europe, Antarctica and South America. Fragments of North America, Western and Northern Europe are concentrated at the equator. The planet is warm and wet, with sea levels hundreds of feet higher than they are now. The giant Panthalassic Ocean engulfs much of the northern hemisphere. Most of the US lies underwater beneath vast shallow oceans called epicontinental seas.
Epicontinental seas would be marine environments, oceans, that covered parts of the continent. And in the Ordovician, we had higher sea level, and much of our continental area was covered with ocean.
The surface of this world is more like Venus than modern Earth. The oxygen level is so low, any animal would struggle for breath.
If you put a human back in the Ordovician, the oxygen concentrations would have been such that probably a simple walk on the beach would have been very strenuous. The land would be extremely barren. It would pretty much look like the land looks today in places like Death Valley. Just no green, no animals. Because of that, also, it would have been extremely quiet. None of the noises that we associate with animals that you would hear in a forest, like birds, even insects, none of that would have been present back in the Ordovician.
The surface world may be desolate, but underwater, it's a different story. This rich seascape will one day be a desert, sitting under the Las Vegas Strip. For now, it's a bustling city in its own right, a vast coral reef teeming with weird inhabitants.
There is a perception, I think, oh, it's ancient, it's 500 million years old, it must have been empty. It wasn't empty, it was full. It was just differently full than we have today. Certainly organisms were living in the deep sea, they were living in the water column, they were living in the sediment, on the sediment. And much of the western U.S. would have been a shallow marine habitat. Much of the middle of the U.S., Cincinnati, and much of the Appalachians would have been habitats that aren't equivalent to anything we have today.
Reefs just like this span the globe. Their warm, sunlit waters are the perfect home for the planet's rapidly evolving life forms. Along these reefs, 2-foot-long trilobites scavenge for food. Related to today's ants, these industrious creatures keep the seafloor clean, gobbling up almost anything they can find. Dead plankton, bits of algae, even animal waste. They share their turf with an evolutionary newcomer, a straspis, one of only a few primitive fish species on Earth. Just 6 inches long, this small creature could fit in the palm of your hand. But this animal has a mutation, never before seen on Earth. A primitive backbone. Astraspis fossils unearthed in the early 20th century revealed a fibrous sheath along its back, used to protect a spinal cord. The very same structure is in our own bodies. It's hard to believe, but this lowly creature is the ancestor of every vertebrate on the planet today. Birds, reptiles, mammals, man. Our existence is entirely dependent on the survival of this single group. And so far, the odds are not in its favor.
These are creatures which weren't very efficient in many ways. They certainly were not predators. They could eat scum and microbes and algae, and they were prey.
At the other end of the food chain, a super predator rules the seas. A merciless killer feared by all. The straight nautiloid.
These are obligate carnivores. These are things that eat meat and always want meat. A 12-footer would be unbelievably scary. You would be swimming for your life, and this thing would be chasing you, and it would eat you if it could catch you.
The great white shark of its time, the nautiloid is a perfectly designed killing machine. Up to 20 feet long, with an insatiable hunger. A straight-chambered shell filled with air keeps this 300-pound beast buoyant. It slices through the sea by inhaling water, then forcing it out through a small, muscular tube at the base of the shell. It's the Ordovician world's version of a jet engine, but with a strange twist. Nautiloids swim far more efficiently backwards.
They have the jet propulsion system, so it's not a constant swimming like a fish. It's like a little piston that swim, 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 swim. You're in the water with a nautiloid. You see the back of a shell. You have to go all the way around it to see the swimming part, because the head, the tentacles, everything goes backwards.
Though nautiloids reign supreme, there is competition. Giant sea scorpions, called eurypterids, routinely challenge the nautiloids for the best feeding grounds.
As repulsive and hideous as scorpions on land are, I think they would not hold a candle in nastiness to the sea scorpions. These things were huge. You had probably 200 or 300 pound monsters. These are the biggest arthropods in the history of the planet.
Eurypterids are enormous, 6 feet long, with some as heavy as a prize-fighting boxer. Their legs, called chelicerae, are covered in bristly spines. The last chelicerae are flattened, forming a type of fin used for swimming. Facing off against a nautiloid, it's like a death match straight out of science fiction.
I think you could probably sell tickets to a fight between those two. I'd give anything to see a big eurypterid tangle with a big nautiloid.
But everything is about to change. Forever. The death rays have already penetrated our solar system and seared through the asteroid belt. A gamma-ray burst hitting Earth is so rare, scientists believe it only happens once every 500 million years. This one will strike before the day is done. For certain is death for the born, and certain is birth for the dead. Bhagavad Gita, 5th century BC. A controversial theory proposes that a massive gamma-ray burst may have struck our planet 450 million years ago, forever altering the destiny of life on Earth. Gamma rays, a form of electromagnetic radiation like X-rays, are catastrophic. Traveling at the speed of light, it takes just hours for the gamma-ray burst to traverse the entire solar system. For the creatures of Earth, there is no warning before the gamma-ray burst hits. This is 0 hour. The gamma-ray burst rips into the upper reaches of the atmosphere with astronomical force. But it's as ferocious as it is beautiful. The deadly rays shatter air molecules, literally busting the atmosphere apart.
Just consider the nuclear arsenals of the United States and Russia. If you were to set off all of those bombs simultaneously, the amount of energy that would be released is just a tiny drop in the bucket of the amount of energy that would be released during a gamma-ray burst.
Just 10 seconds after it began, the light show gives way to an eerie calm. It is broad daylight, but there is a strange companion star next to our sun. This is the burning embers of the supernova, an extra light in the sky that will flicker for a few months, then disappear. With no animals on land, the light show passes unnoticed, an awesome spectacle played to an empty theater. Life seems to go back to normal. But the future of every species alive today, from the lowliest insect to the human race, is now hanging by a thread. is now 24 hours after the gamma-ray burst. Extinction begins at the microscopic level. In the upper reaches of Earth's atmosphere, the gamma rays have destroyed 30% of the protective ozone layer. Now, ultraviolet radiation from the sun is able to pour in. The light is unbearably harsh, 50 times more intense than at the Sahara Desert.
Well, let's just say if a gamma ray burst hit the planet, every tanning salon would go out of business, no longer necessary. Anything on land would definitely be fried.
Unseen to the naked eye, the planet's plankton, the microscopic animals and plants that float near the ocean's surface, are the first to feel the effects.
If you could take a drop of water from the ocean and put it on a slide, look at it under a microscope, you'd see all kinds of tiny things teeming within that slide. And basically, those tiny things are the things that bigger things eat.
The life-giving sun burns the majority of these organisms to death. The entire base of the food chain is wiped out.
If you disrupt the phytoplankton, the most immediate effect is going to be on those animals that are feeding on the phytoplankton. These tend to be very small animals. Often they're arthropods.
Now lack of food joins the harsh sunlight, wreaking havoc on the plankton feeders. The surface water used to be a nursery for many tribalite species, but the lava can't survive the scorching UV rays.
It's like an atomic bomb attack. It's the radiation you don't see. You can't see it. You get sick. You don't know why. It's just in the air. With the death of so many of the corals and the animals on top, the whole food chain begins to collapse. And so down through the food chain, it's like dominoes toppling.
The UV radiation is most intense in the tropics. Coral reefs begin to die. The disaster spreads from there. In almost every corner of the globe, coral reefs are starving to death. The devastation ripples up the food chain. More and more animals suffer with hunger pangs. As the weeks go by, the destruction of coral reefs grows.
Corals are composed of an animal, yes, but they also have tiny plants in their flesh. They're called zooxanthellae, and they pull out of the flesh, they swim off into the oceans, leaving the coral without them. Very quickly, we would have started seeing this whole thing turn into this ghostly, bony color.
Only 3 months have passed, and yet the side effects of the death rays are felt far and wide. Mating season for these coiled nautiloids is in full swing. These cousins of the straight nautiloids are generally small, just the width of your hand. But the coiled shell is a much more maneuverable design than the straight shell. Mating rituals are more important than ever. The survival of the entire species is at stake. The females pursue the males. The more colorful his shell, the more irresistible she will find him.
Reproduction had an awful lot to do, I think, with who survived and who didn't. The way you reproduced may have had as much to do with survival or not as the mode of life of the adult.
The world may be collapsing around her, but she's determined to secure a future for her offspring. Her eggs will incubate for the next 8 months. Only time will tell whether this mother's efforts are in vain. The study of mass extinctions is one of the most controversial fields in paleontology. The scarcity of fossils, the contradictory evidence, and difficulty in verifying the causes of these disasters makes for a heated debate. How do scientists really know that mass extinctions occurred in the distant past? The Earth itself holds the key.
as geologists began to really start collecting fossils for the first time. They realized that there were fossils that were present within a specific group of rocks that weren't present above. But at some of the rock divisions, there would be wholesale disappearance.
What these early geologists found was the first evidence of a mass extinction. Modern scientists carry on this legacy, scouring rock formations all over the world for clues to the true nature of these epic catastrophes. In the deserts of the western United States, rocky outcrops that once formed the Ordovician sea floor contain thousands of fossilized animals. These rock formations are a record of the entire Ordovician extinction event.
These fossils have been broken up. They died, went through a storm, and that's what breaks up the fossils and makes the rock much more difficult to look at, and much prettier because we see a lot of fossils in it. This one has some nice solitary rugose corals, the horn corals. The little circles with a hole in the middle are the stems of the crinoids. The crinoids are those animals that lived on the ground and they were echinoderms related to starfish. The brachiopods were bivalve shells, not related to mollusks or clams, but their own group of fossils that were one of the most dominant groups in the Ordovician.
This is where the mystery of mass extinction is unraveled by modern-day scientists. According to a controversial but compelling new theory, a gamma-ray burst produced by a nearby supernova may have triggered the first great mass extinction in the history of the planet. The death rays set in motion a horrific chain reaction that threatens all life on Earth, present and future. 8 months into the disaster, the world is drastically changed. The shattered molecules of Earth's atmosphere swirl around the globe, forming a witch's brew of toxic gases. Atoms realign into nitrogen dioxide, the noxious brown gas we know today as smog. The thick blanket of putrid air blots out half the sun's rays, while temperatures plummet 10 degrees Fahrenheit. In northern Europe, the drop in water temperature is bad news for the coiled nautiloids. Their eggs, laid months ago, aren't developing normally. The cooler water temperature has slowed down the embryo's growth, an open invitation for hungry bacteria to move in and consume the developing nautiloids. The species is in jeopardy.
Organisms are adapted for their local environment. If that environment changes, they're in trouble. If it changes extremely, they'll die. If it changes just a little bit, they'll still live, but they won't reproduce.
The few hatchlings that do make it are thrust into a harsh and unforgiving world. They'll spend most of their short lives searching desperately for food. And still, they're doing well compared to other species. It is now 10 years after the gamma-ray burst. In southern Mexico, the change is stark. The temperature of this reef has dropped 20 degrees, accelerating the destruction of the food chain. A once vibrant habitat is now a dingy graveyard.
As temperatures cooled, those animals that could move did, but so many of the animals in the Ordovician were not movable. These things grow in place, solitary, the corals, the brachiopods, the sponges. There's no picking up and moving. You're there for the duration, for better or for worse, and as it got worse, that was the end for them.
Calcium carbonate makes up the shells of many of the animals that form a reef, and calcium carbonate physiologically is difficult to secrete in cold water. Cooler water meant much more difficult times for these organisms. They couldn't build as much calcium carbonate. The reefs essentially died.
This is another catastrophic side effect of global cooling: deadly and unpredictable weather. The climate was incredibly stable, not anymore. For the first time in millions of years, there are big temperature swings creating strong ocean currents, which in turn drive more violent weather. It's like a never-ending wave of Category 5 hurricanes sweeping the globe. Weakened reef animals are smashed against the rocks. Those that still have some strength left seek shelter away from the turbulent surface water.
An escape for these guys would have been, let's go deep. Certainly that initial sense of their safety and depth would have taken hold. And you see all these long cone nautiloids crash diving. Just this huge herd of things heading for deeper water.
But the dive to safety carries hidden danger. The water pressure is too great for their long, straight shells. The ultimate irony: the planet's greatest predator is now its victim. Their cousins, the coiled nautiloids, have tougher, sturdier, spiral shells. They can wait out the storms in the deeper, more stable water. Year-round violent storm systems pummel the Earth. The future is looking bleak. The dead wash ashore on coastlines across the world. With no surface animals to scavenge their remains, their bodies pile up by the thousands, like casualties of war. 500 years after the gamma ray strike, a third of the world's animals cease to exist. And for those creatures still struggling to survive, there's little hope. All life on Earth is teetering on the brink of extinction. 450 million years ago, Earth endured its first mass extinction. A controversial theory contends that a lethal gamma-ray burst slammed into Earth, tearing apart our atmosphere and damaging the protective ozone layer. Intense sunlight poured in, destroying the food chain. Starvation set in. Then the double whammy. The air transformed into a thick blanket of smog, blotting out the sun, resulting in plummeting temperatures across the globe. "150,000 years after the death rays struck, life on Earth is in shambles. The few surviving species live in constant hunger. Nautiloids were once the invincible rulers of this domain, the killer whales of the Ordovician. Now, weak and sickly, they are desperate scavengers. For them, the world is vastly different. Year by year, the planet is getting colder and colder. What you're witnessing is the birth of a new ice age. Snow piles up at the South Pole, and over centuries, it compacts into solid sheets of ice, immense, mile-thick glaciers that slowly march north across Gondwana, a supercontinent situated over the South Pole. The growing glaciers suck up vast amounts of ocean water, causing sea levels to drop by up to 200 feet.
The water was taken from the oceans and sea level declined. The more ice, the lower the sea level. And eventually it drained the continents of their shallow seaways. And the organisms living in there had no living space. They died.
The loss of the shallows wipes out more of Earth's population than the gamma ray burst itself.
In a sense, it's the opposite of what we're worried about today, right? So right now we're in a glacial period, and we're worried about the glaciers melting, and you see maps of North America and sort of, well, there goes Florida, there goes Manhattan, there goes, you know, all the lowlands. And so basically this is the reverse. Quite a bit of continent gets exposed when you tie up water into widespread glaciers.
In this new ice age, some animals prove remarkably resilient. Our ancient ancestor Astraspis follows the receding ocean water. This early vertebrate endures cold water better than other sea creatures. Even more critical to its survival is its indiscriminating palate, which allows it to eat anything that's available.
If you're a picky eater, you were really going to be in trouble. You probably had to eat almost anything to be able to get through one of these crises when food was at a premium. If you're a very narrowly adapted carnivore and your particular prey goes away, you're extinct.
Astraspis is adapting, even flourishing through the hardship, and soon an entirely new variety of fish begins to evolve. In these new species, the bones and muscles that form the first gill take on a new function, sorting and moving large food particles down the throat. Every jaw in the vertebrate world, whether it's used for chewing cud, taking down prey, or the simple act of speaking, is the result of this remarkable adaptation. Another animal that's persevering is the Eurypterid. This predator also followed the receding ocean water and managed to survive by taking over the nautiloid's niche in the food chain. On coastlines across the world, the drop in sea level creates bizarre landscapes. The skeletons of coral reefs are now jutting above the surface. Where straight nautiloids once ruled, now a handful of weary survivors search the wasteland for any scrap of food.
So many animals and plants are narrowly adapted, and any sort of cooling, especially for tropical creatures, is a death sentence. Take an enormous glass jar and put it over the island of Hawaii, cool it off for 3 months, and come back and see how many of those plants are alive.
As the glaciers forge their way into the subtropics, huge icebergs appear. Beneath the surface, they threaten to destroy everything in their path. As mountains of ice steamroll their way towards the equator, coral thousands of years old is ploughed over, causing massive devastation. A 250,000 years into the extinction, sea levels continue to drop, and thousands of square miles of marine habitat are exposed to the harsh conditions of the surface world. Sun, wind and rain erode the reefs, transforming them into vast, barren deserts. Year by year, life retreats with the receding ocean, condensed into ever smaller habitats.
This is forced migration. This is migration maybe to a better place, but maybe not. Water temperatures, ocean currents would have changed. Conditions of a tropical world would have gone temperate and finally to frigid. So all of this would have contributed to extinction.
An exploding supernova has brought horrific devastation to planet Earth. But this mass extinction is not over. Must not all things at the last be swallowed up in death? Plato, 4th century BC. It is now 550,000 years after the gamma ray burst. Freezing conditions have annihilated 2/3 of the world's animals. But then, temperatures rebound, the glaciers melt. Species that survived the Ice Age struggle through yet another extreme environmental change. As always, luck factors heavily into who will survive.
As we look at the Ordovician extinction, the one thing that really stands out is that the best way to survive is to be very widely distributed. If the same species is present on 5 or 6 different continents, it has a very good likelihood of survival. If it's present only on one continent, it's very unlikely to survive.
Straight nautiloids make a surprising comeback, but they're a shadow of their former selves. They used to grow to over 20 feet. Now they're half that. They are far weaker than their ancestors and under constant threat of attack. Unlike the once dominant nautiloid, the Eurypterids have fared well through the extinction. The roles of predator and prey are now reversed. The oceans become a bloody killing field, but this time the Eurypterids dominate. In this changing world, these sea scorpions are exhibiting a curious new behavior. Once they make a kill, they often drag the carcass towards shore. And incredibly, some of them are even venturing onto land. It is possible that the shifting sea levels may have accelerated the evolution of air-breathing book lungs like those in modern insects. Inside the Eurypterid's abdomen are stacks of air pockets resembling a folded book. The scorpion's blood circulates through this tissue, pulling oxygen out of the air. An amazing adaptation born out of the will to survive.
The mass extinctions are like dumping fertilizer on a newly weeded garden. You get a lot of stuff back. Some you can expect and some is totally new. Had that mass extinction not have happened, I can guarantee that the types of animals and plants we have on the planet today would be different.
But in these same waters, there's another remarkable evolutionary trait emerging. A small pocket of fish, relatives of Astraspis, have developed a unique trait: movable jaws. They are called acanthodians. They swarm anywhere there's a carcass. Their new adaptation allows them to nibble flesh off prey instead of waiting for morsels of food to float by. From their humble beginnings as algae suckers, fish are now moving their way up the food chain. Mass extinction transformed winners into losers, the hunted into hunters. Different roles, but the cycle of life and death continues. Life will continue. To everything there is a season, a time for every purpose under the sun, a time to be born and a time to die, a time to kill and a time to heal. Ecclesiastes, 3rd century BC. It is now 700,000 years after cosmic death rays triggered the first mass extinction. The planet seems to be shaking off the effects of the disaster. The Earth awakens from its cold slumber. But the toll is sobering. Reef systems in the Earth's shallow seas are especially hard hit.
Reefs, as a rule, get hit hard during mass extinctions. Reef organisms are always more sensitive to environmental change. They have a restricted ability to live in diverse environments.
Over 70% of all species will never be seen again.
By analogy, today we can think that scientists have described about 1 million species, and so 70%, that would be about 700,000 species going extinct over a relatively short period of time.
But Earth is remarkably resilient, and life advances once again. In Earth's next chapter, called the Silurian period, astounding new species repopulate the empty oceans. It is now 3 million years after the gamma-ray burst. Earth returns to a tropical greenhouse climate. Sea levels rebound, restoring vast stretches of shallow ocean habitat. Bizarre new animals evolve alongside many familiar creatures from before the extinction.
The effects of the Ordovician extinction are kind of interesting. If you look at it in terms of the actual changes in the ecology, it's probably the least effective of the 5 great extinction events. A lot of animals went extinct, but the diversity, the different kinds of organisms that were going to re-evolve afterwards, pretty much the same.
In the open oceans, fish with jaws, like the acanthodians, swim alongside their more primitive, jawless cousins, like Astraspis. They even begin to invade freshwater lakes and streams on the continents. Once a rare and lowly life form, fish are now taking over our planet. Every fish we know today, catfish, swordfish, minnows, sharks, will all be spawned from these ancient ancestors. As the centuries pass, incredible new varieties of these remarkable creatures spread from pole to pole, unaware of what their ancestors suffered or how fragile their world really is. Fearsome new predators await them in these habitats, including a super eurypterid called Pteregatus. No more large nautiloids to thin their population, sea scorpions have evolved into huge monsters. The crocodile-sized Pteregatus is the most feared predator of the early Silurian.
The claws themselves had long needle-like extensions so as to better grab prey or eviscerate prey or stick through the meat of prey. They had big jaws, they were capable probably of fairly rapid swimming, but the scariest aspect is that they were huge.
Schools of fish make easy pickings for this beast, which can charge at an explosive 8 feet per second. For the fish, survival is all about numbers. Traveling in schools means they can afford to lose a few individuals and still preserve the community. Life in the Silurian continues its dramatic spread into new habitats. Again, the world pulses with life. Slowly but surely, diverse animal species invade and colonize the Earth's oceans. Our planet has endured numerous mass extinctions. No one can predict when the next one will strike, but as sure as the cycles of day to night and season to season, we will be tested again. If a gamma-ray burst were to strike Earth in the future, there would be no warning. In fact, death rays could already be on their way.